Alright, good evening. This is Unit 1, Video 9 on calculating slope. So we're going to start just with a little bit of an introduction, and this is definitely going to be a conversation that continues in class. But special to a straight line is the slope, and slope is a measure, a numerical measure of steepness. Okay? And it's unique to a line in that it is a constant. So I'm going to give you just a brief explanation of calculating slope under its definition. So m equals delta y over delta x. Now, what is delta? Delta is a Greek letter that means change. Its symbol, a Greek letter, it's actually the letter, is a triangle. So we're talking about the change in y, or the vertical change. And change is found algebraically by subtraction. If we want to know the difference between two numbers, we use subtraction. So this would be y2 minus y1 if we're looking at two ordered pairs. Well, this is the numerator, whereas delta x in the denominator is the change in x, or the horizontal change. And horizontal measurement is done as x2 minus x1, again using subtraction. So if we use delta y over delta x equal to y2 minus y1 over x2 minus x1 for x1 comma y1 and x2 comma y2 on a line, then we will have a value for slope. Now we need to note that in this, this should be an x, I apologize, that we need to note that delta x cannot be 0. To calculate the slope between two ordered pairs, we'll use negative 2 comma 5 and 7 comma 4, and I want to find delta y over delta x, and I can use 4 minus 5, those are my two y values, divided by 7 minus negative 2. And this will result in a slope of negative 1/9. I can also find slope of these 2 points. Delta y over delta x, my vertical change, 6 minus 0, my horizontal change, negative 3 minus 4, 6 over negative 7. Which could be written as negative 6/7 as well. Try this one on your own. So the result of the slope between these 2 points is 1/8, or 1/8. Be careful here with all of the negatives that we have. Last thing we're going to look at is special slopes. And our special slopes, I'm going to refer back to our definition of m equals delta y over delta x and we wanted to say that delta x could not be 0. Well, what if delta x equaled 0, then we would have, well, we would have a 0 in the denominator, which we know we do not want, but we would also be really looking at, on a graph, that there is no horizontal change. If delta x means horizontal change, or the change in your x values, then there is no horizontal change. If there's no horizontal change along a line, I'm not moving left to right as I go from point to point to point, then we must have a vertical line. Let's calculate the slope here. Delta y over delta x equals -1 minus 2 over 4 minus 4. I will have -3 over 0. I have no horizontal change. If I have no horizontal change, my line is vertical, my slope is undefined. Well, what if delta y equals 0? That would imply that there is no vertical change. And with no vertical change, no change in the vertical direction, this will result in a horizontal line. Let's calculate the slope for this one. So I have delta y over delta x to equal -4 minus a -4 over 5 minus 3. I have 0, no vertical change at all, over 2. My slope is 0. My line is horizontal. Please give the problems on page 222, numbers 35 to 42, calculating slope. Give those a try, and we will see you in class tomorrow.